This is video number 19 for things not working, and it is called Cutoff Routine Enable Cutoff Distance Parameter. It should say there. So the cutoff parameters and the cutoff routine in IRIC mimic the cutoff capabilities in MATLAB. These capabilities allow a cutoff to occur at specific conditions. And those conditions are simulated by adjusting different parameters in the cutoff parameters dialog box. Now there's an issue with this box right now, and there may be more than one issue with the parameters in this dialog box. And I'll make separate videos for each one if that's the case. But this one deals with how the parameter that's called enable cutoff distance seems to negate or override other functions in the parameter cutoff box. Okay. First, we're going to take a look at the parameter dialog box and how it works when the distance parameter is not enabled. And I'll show you how the functions work when they're working. Okay. In this scenario, we have the cutoff parameters dialog box that I've been talking about, and we are enabling the cutoff routine. But we do not have the cutoff distance routine enabled. It is disabled. We have default values for the parameters of sinuosity, the cutoff recurrence interval we're not using yet, the upstream cut factor of 0.25, the downstream cut factor of 0.1, and the bend distance threshold is not activated because the bend distance routine is disabled. Okay. And we have, for our erosion algorithm, we have a fixed FD of 30. Now, I have run that and saved the values to QGIS, and here's what you get. Okay. You see the cutoff that has been modeled, and you see the upstream and downstream locations corresponding to where it initiates cutoff and ends cutoff. And the upstream location is 0.25, which means a quarter of the way back on the preceding bend. The downstream location is 0.1, which is about a tenth of a way down on the other bend. So that is how the upstream cut factor and the downstream cut factor work. Now, if we change our conditions for the upstream cut factor, for example, we put in 0, and downstream we put in 0 also, and then we run them with these, we'll compare it to the previous run. And I have done that. And I'll bring up the results of that run. Turn this off for the moment. Show you this one. Okay. It gets to the inflection point, 0 distance in this way, and it gets the inflection point over here, 0 distance there when it cuts off. Now you see how it differs from the previous one. That's where the cutoff upstream and downstream points were set by the parameters, and you see how they compare to each other. Let me do a little bit of toggling back and forth. Here you have it with the quarter and 1/10. Here you have it with the 0 and 0. That's the 0 and 0. That's that one. You can see it's a significant difference if you had chosen them to cut off and model it in those two different ways. Now note that these parameters simply control where the upstream and downstream end of the bend cuts off. they don't control at what condition the bend actually cuts off. So the criteria we've been using for whether it cuts off, and let me perhaps go back to here. Criteria we've been using for whether it cuts off at all and what conditions are required for it to cut off is the sinuosity. It reaches a certain sinuosity and then it cuts off. In our example, we've been using the default sinuosity for cutoff on the Sacramento River of 1.8. Now, what if we change the value of sinuosity? In this case, I'll just try 2.5. Okay? Well, having done that, these are the results we get. So let's compare this with the previous value of sinuosity at 1.8. So I activate this, which is just a copy of the critical center lines here. Turn off some of that and show you the 1.8. Okay. The green, which is 2.5 sinuosity, is more sinuous. It's more curvy. It's a tighter bend. And it gets tighter before it cuts off. That was the criteria. We wanted to set the sinuosity as the criteria for cutoff. So, this is an example of how these particular cutoff parameters work. And it's background information for the next issue, how the distance routine interferes with this. So the distance routine was designed to be extra value. Okay? Let me show you. So when we enable the distance routine, the way it's supposed to work is that it adds an extra check to the conditions. If the sinuosity, in this case, is 2.5, then you also have to have the bend distance be, in this case, 680 meters or less across the neck for it to cut off. If the sinuosity is appropriate but the distance too far, then it doesn't cut off. But the cutoff, upstream cutoff factor, the downstream cutoff factor, and the sinuosity are all intended to work when the enable cutoff distance routine is enabled. Okay. Running it with the conditions that I show you on the screen, we get this. Okay? And let's look at the output. The message may not be completely obvious here, but note that all we did was turn on the distance checking parameter. It worked, but it overrode everything else we wanted. For example, here is what the sinuosity of 2.5 cutoff looks like. What it's done, it looks like, is it's defaulted back to 1.8. But it hasn't even done that exactly, because there's the 1.8. So what it did do is that it cut off when it got to 680 meters, and it ignored everything else. So it overrides the sinuosity where it was meant to supplement the sinuosity. And it was meant to say, if it has a sinuosity of 2.5 and a cutoff distance of 680 or less, then it will cut off. And right now what it's doing is no matter what the sinuosity, when the distance between inflection points gets to be 680 meters or less, cutoff is invoked. And here's another rub. The cut locations are put back to 0. Now that's not obvious here, but I'll show you that now. As a further test, with this distance routine enabled, I changed the settings of the upstream and downstream locations of the sinuosity. So I went back to 0.25, 0.1 in this particular run, and here are the results that I got. Okay? Again, let's compare these. Now remember, I have just changed the upstream and downstream cut location, and we'll compare these with the last condition. That's 2.5. And this is the run that I want. And what you see is that they are identical. So there's no difference. So when you have the distance routine enabled, the upstream and downstream cut factors do not work. So, in summary, when I test the cutoff routine in the IRIC platform, the distance checking parameter overrides the functioning of 3 of the other factors, so that they don't work. It overrides the sinuosity threshold, it overrides the upstream cut factor, and it overrides the downstream cut factor. Now, I have tried the same thing in MATLAB, and I get the same set of parameters not working in MATLAB when the distance routine is invoked. It's not clear to me when the correct functioning ceased to work in MATLAB, because I can't actually run previous versions of MATLAB. When MATLAB upgraded a while back, it did not make itself backwards compatible. And so at one point, I believe Frank helped in updating the MATLAB code from one version of MATLAB to the other. And I've tried to edit the MATLAB code in order to do it, but I'm unsuccessful in doing that too. One guess that I have is that the distance routine is being called after the other routines. And rather than respect the values for sinuosity and location of upstream and downstream cutoffs, it's overriding those with default values when the distance routine is invoked. Whatever the cause, this feature needs to be fixed for a smoothly running IRIC meander code. Okay, thank you again.